Alright, this is my demo for the GAM475 graphics engine. I'm going to talk through some of the features that I implemented, some of the ones that were required. So to start, I have a game object management system. Here, the game object manager it's a singleton, and it has a PCS tree that holds all of the game objects in a hierarchy. You can add an object directly to under the root node. It can add under a specific node. It can get the root. It can update all of them using an iterator. It can draw all of them using an iterator. It can delete the last object on the whole list using a reverse iterator, and it can cycle through the textures. I can transform many complex operations into one resulting world matrix over here. So in my game object class, I have a world matrix. I have an intermediate movement matrix that's used to do operations on any objects lower down in the hierarchy underneath a specific object. I have a translation vector, a scaling vector, and I have several different floats. These all control the current general rotation of an object and the change in each of these values that I want to set, and these control the self-rotation of an object, its own rotation on its own axes as if it was spinning in place. And again, these control the amount that I want to rotate these. Here in the game object class, I can combine several of these together. I can create these matrices. I can multiply them together. I'll get into this a little bit later. And I can control each of the game states. I have a camera object. I create a single camera object here in the beginning of the game CPP file, and I add it to the camera manager. This camera manager will hold this camera, and it will be the active camera. I can also add several other camera positions, and this will allow me to switch between various different cameras during the demo. I can move the cameras using keyboard keys, and I'll get to that later as well. I have several different textures. So just going through this a little bit, I have 4 different models: the cube model, a pyramid, a diamond, and an L-shaped. And the L-shape I actually made myself. I wrote the vertices myself, and I saved it to an output file, and all 4 of these I load from their own data files. I have 4 different shaders, one for color, one for texture, one for texture with light, and one for color with light as well. I have 4 different textures: rocks, stone, red brick, duckweed. I instantiate several different graphics objects and 2 game objects, and I can do multiple instantiation. I can instance different objects at different locations with different transformations, with different attributes and different shaders. Okay, yeah, so I'll get into the demo and go through a little bit of this in more detail. So this is my demo. As you can see, I have around 5 or 6 of each different object type. I have the cube, the pyramid, the diamond, the L-shape, and each one of these is represented in a different way in different locations. The cube here is rendered with a flat texture. Around here it's rendered with the color by position, with the color with lighting, as you can see with these 2 different green shaded ones. Is represented as a wireframe. The pyramid also color by position, different textures, wireframe. The diamond, same deal. The L-shape, same deal. So yeah, I load these objects from a file. I can swap the textures between any of the flat textured objects by pressing the letter T. So this will cycle between all the textures that are available on the texture manager, and it'll go to the next one and the next one for every single textured object. I can move the camera around with the left, right, up and down arrows. So that's left, it's right, it's up, it's down. I can zoom in and out with the I key and the O key respectively. I will zoom in, move this around. O will zoom out. I can switch between the 3 different cameras with the 1, 2, and 3 number keys. So 1 will set it back to where it started, 2 will put it behind all the objects, and 3 will change the actual target, what the camera is looking at, as well as the position. So here, if I move the camera around, it's now focused on this middle L-shaped object. And of course I can zoom in, I can zoom out, I can change all the textures. So as you can see, there's a lot going on with these objects. They're all organized in some sort of hierarchy, and they all move based on a very specific set hierarchy of the objects. So for example, here there's an L-shaped object rotating around its own axis in the middle. There's 4 different objects rotating in a counterclockwise fashion around. And even here on this diamond wireframe object, there are 4 even smaller objects rotating around those. And you can see here that even as some of these objects are rotating around another object, they are also rotating around their own individual axes as well. Same for these smaller objects rotating around this diamond wireframe. Looking back at this main cube, all of these objects are set at a different depth, but they're all rotating with respect to this cube. And this L-shaped object is rotating around the cube. It has several other objects rotating around it. And as you can see from this angle, even the L-shaped object, the objects rotating around it, all rotate around their own individual axes as well. I can delete objects by pressing the letter D. This starts to delete all of these objects off of the tree. I can still go back, change my camera to this. I can still zoom out. I can still zoom in. I can switch the cameras. I can switch the textures. Everything still works. So going through this code a little bit more, I create the objects here, and for example, I'll create a flat textured object. This will be the red brick cube, the big one in the middle, and I can set its own rotation around the Y and around the X. This will again be the rotation that an object does on its own axes. And then I can add it to the object manager, and it will be added right underneath the root node. I can also add other objects. For example, here I'll create multiple instances of the game object 2 and add them underneath the game object, which is how I get them to rotate around a specific object. I can set the general rotation around a z-axis, and that'll be its general movement in space. And I can also set its self-rotation around the y-axis, which will be its own rotation on its own axis. I can do this for multiple objects. I can get different keystrokes in the keyboard test function in the input test class. So for example here, I get a keyboard. I can check 1, 2, and 3 and set the camera position based on that. I can get input for the letter T and cycle through the textures. I can get input for the letter D, cycle, delete the last object on the game object manager list, starting with the first on the reversed iterator. I can get the I key, the O key, any of the arrow keys, and change the camera position based on that. I can also get the mouse input, but I didn't really add any functionality to incorporate that. Going a little bit deeper into game object, whenever I call update, it'll go through the forward iterator list, update each game object, and here's where you can see, wrong view, here's where you can see it'll call private update, and this is where some of my own added functionality kicks in. I'll first set or update all of the different rotations, so the general rotations in larger space and the object's own rotations around its own axes. I'll create matrices out of all of these in the local space, or the local scope. And then here's where this intermediate matrix is used. I'll multiply the translation and the 3 rotations for the current game object. Then, if the object has a parent object in its hierarchy and an actual parent object, not a null game object, if it has this sort of object, I will get the same intermediate matrix for that parent object, and I will multiply this movement object for this game object by the parent's same matrix. This will give me a specific hierarchy of motion for objects around other objects. Then I will go ahead and set the actual world matrix. I'll multiply the scale of this object times the self-rotations for this object times this larger intermediate movement matrix. And so here's how that works out. Here, each one of these 4 objects rotating around this diamond wireframe, they all have scale, they all have their own rotation on their own axes, so if you were to look at one, it would be spinning on its own axes. And then it will get the movement matrix for its parent object, which is this diamond. And this diamond object is moving counterclockwise around this L-shaped object with a certain translation and rotation. And it's also spinning on its own axes as well. And then for even going further up the hierarchy, this diamond object will be multiplied by the movement matrix for this L-shaped object, which spins on its own axes but has a translation in space from the origin of the screen. And this allows me to get this sort of complex motion. Same thing for this L and the object surrounding it. The L-shaped object rotates clockwise around this cube. These objects rotate around the L. And looking from this angle, each one of those cubes also rotate around their own axes as well. So yeah, this is my demo. One of the features that I didn't really have a chance to implement is implementing an interface to change the min-max filters for the textures, as well as the clamping and wrapping modes. I didn't really implement those here, but I hope to do that in the future. In general, this demo was very insightful in terms of how I approach my own development, and I'm definitely looking forward to continuing my development process going forward in the future game engine classes. Yeah, thanks for watching.